Today we will introduce how to identify the resource of natural gas. This introduction is only for reference. How to apply in your predict condition, please refer back to your instrument and your analysis engineering recommendation. The target we introduce is to identify the resource of the natural gas. The method we are using is to identify by the isotope rate analysis. In the analysis, we will have 3 parameters that will be given after your data was being recorded. First is the isotopic rate. Second is the rate between the sample and the standards. The standard for carbon, we are using carbon dioxide as a standard. The third is the percentage of isotope in the total atoms. These 3 parameters will be given in your data table, and we need to pay attention is this third. This third is the rate between the sample and the standards. The equation to obtain this theta will follow this highlight in the red, but in your result this one normally is already given. So how the result was obtained is the isotopic rate of the sample will be analyzed by the mass. Then the data will be displayed in one of the columns as cited in your table. You can find it. And another is the rate of the standards. This one you can refer in next page. Here is the isotope rate of the standards. The standard for each element, what the standards are using to obtain the isotope rate for this element is all listed here. You pay attention to the carbon. This is the one we are going to use. This data is based on the IEA and NIST standard. You can refer to the introduction from other agent, maybe training center or standard introduction. We will identify the resource based on this chart. You can see in the target of our that highlight in the green and the red is very significant different. So you can use this carbon 13 to identify exactly how is your natural gas come from by the analysis of methane. This data we have already obtained in our last analysis, so you can refer back to the data and to check which range you are allocated. If it's allocated between 47, 45 to -20, it will be thermogenetic, and otherwise it will be biogenetic. And the resource of the chart is coming from this book. You can resource from us about this book, but it's only for research and study purpose, not for selling or any commercial use. There's also other books in our database. If you're interested, you can refer from the book list cited in the introduction part. So how the data obtained is based on the procedure cited as below. In our case, we have analyzed carbon dioxide and the methane. The instrument used is isopropyl 100. This is the mass series number. You can refer and check more introduction from the website. And the procedure to obtain the carbon dioxide, including inject sample in gas phase, is gas sampler. That's your sample sent in gas bag. Then the gas will be carried by helium to the trace gas. Trace gas is a gas purification that can remove water or other related gas that we don't need. After this one was being water was being removed, then the 4 ml sample was injected in the system for analysis. Then the extra water was removed by a naphthalene membranes. Use a Q column to separate to obtain the pure carbon dioxide. That is our target for analysis. We will inject the separated gas into the mass for analysis. Because our standard is a carbon dioxide that used for quantification, so we obtained the quantity data for our carbon dioxide in our sample. This is how the carbon dioxide was obtained. You can see from this chart that the sample passed through the purification, then sampling, condensed into the liquid nitrogen trap, and going to extra remove the water and going for mass analysis as introduced in the previous page. How the methane was obtained is a little bit complicated than the carbon dioxide, because we need to remove other carbon materials before we analyze the methane. We will keep methane only, then transfer it into carbon dioxide for further analysis. We introduce from this chart. We can see here is when the sample was injected, it will pass through the trace gas to remove the water. Then after remove the water, use oxidation to transfer the carbon monoxide to carbon dioxide and remove the carbon dioxide by the cold trap. Then later the extra gas that will contain only methane will using oxidation under high temperature, here cited is 1050 degrees, to transfer the methane into carbon dioxide. Then this sample until now will follow the similar procedure as we analyze in carbon dioxide for the analysis after extra removing water by naphthalene membranes. This is how the data we obtained. So you can refer back to the zeta value to identify the resource of your natural gas after you see your result.